One particular kind of problem that you will end up doing from time to time, twice over really, once right now when pulleys are ideal and once later when they're not, is something called an Atwood machine. An Atwood machine sounds like it might be kind of complicated, and it's really not. Here is the idea. I have a pulley. I have on one side of that an object, and on the other side of it another object. These objects can have different masses. Let's call this one 4 kilograms. Let's call this one 2 kilograms. Go mass 2, mass 1. I would like to find the acceleration of the system, and I'd like to find the tension. Here we go. The big thing right now is that this pulley is ideal, so there's nothing going on with that. There's no mass to it, there's no friction in it or anything like that. So it rotates freely, which means the tension on this side of the rope and the tension on that side of the rope are going to be equal. So mass 1, which was 4 kilograms, the forces I have acting on this, I have gravity going down, and I have tension going up. Now I want to look at this because I'm going to need some kind of coordinate axis. If I let go of this system, it's going to rotate this way. So I'm going to call down the positive direction for this, because that's the direction my whole system is going to move anyway. I might as well have it be positive. Now for the other mass, mass 2 is 2 kilograms. I'm going to have the exact same free body diagram. I've got tension going up. I've got M2G going down. But here we go. If downward is positive here, that comes from wrapping that axis around my pulley. So over here, upward is going to have to be positive. Now I'm ready to solve the problem. If I write my sum of forces equation, I get that my sum of forces is, I've got M1G going downward, I've got tension going upward, and together that equals mass 1 times acceleration. I'm just always writing sum of forces equals MA. This equation has 2 unknowns in it, so I'm going to have to keep working. I'm going to look at mass 2. My sum of forces equation for mass 2 is, I've got tension in the positive direction, I've got M2G in the negative direction, equals mass times acceleration. It's a free body diagram and an equation for mass 2, so it's mass 2 times acceleration. I have the same 2 unknowns in here, so I would like to take these 2 equations and add them up. The reason I want to do that is because I see a negative t and a positive t, so when I add those together, those will cancel. The other way that I could do this would be to take this maybe second equation, say I'm going to solve for t equals, so t equals m2a plus m2g, then plug that whole thing in for t here and simplify. But if I can just add these equations, that's going to be fast. m1g minus t, there's the top equation. So now the left side of the bottom equation plus t minus m2g equals right side of the first equation plus the right side of the second equation. I have a negative t and a positive t, which was the reason I did this anyway. So on the left side I am left with m1g minus m2g. On the right side I'm going to factor out that acceleration. I would like to, on the left side, factor out gravity. Now when I solve for acceleration, I get m1 minus m2 times g over m1 plus m2, and I can put in those numbers. And I have my acceleration. The other thing that I needed to find was my tension. I'm going to take one of these two equations up here and plug in for tension. I'm going to take this bottom one and plug in to find tension. So what I have right now, tension minus m2g equals m2a. I'm going to leave that now not in red because I already found it. So my tension is m2a plus m2g, and I get a tension force. I could have plugged into my top equation instead of the second one, and would have gotten the same result. I chose the second one just because t was already positive, so it was going to be just one step faster to solve for, that's all. That's it. That's the idea of an Atwood machine. It's mostly coming down to, like, here's of course the math part, but it mostly comes down to drawing a free body diagram and recognizing a consistent direction for the axis that axis wraps over the pulley. Once you've got that, the rest is just a whole lot of math.